Welcome to Pratham Science Academy classes. And in this video, we are going to solve uh, maths question paper that is of 2023 and set 1 of code 311. And let's get started with the first section, which primarily consists of MCQs. So this is our first section, A of multiple choice questions, and each question is of 1 marks each. So our first question is the graph of polynomial, the graph y is equal to px. Let's say, so this is a polynomial function and graph of this polynomial p of x is given. We have to find the number of zeros from the graph, and we know that the number of zeros is actually the number of points at which this graph intersects the x-axis. So there is only one point where this graph intersects the x-axis. So correct answer for this is option B, which is 1. Now, for second MCQ, we have to find the value of k for which the pair of equations. So let's write down the pair of equations. The pair of equations are kx is equal to y plus 2. So this is now kx minus y minus 2 is equal to 0. And next is 6x is equal to 2y plus 3. So this is 6x minus 2y minus 3 is equal to 0. Okay, so these are our two pair of equations. Okay, now it's given that this pair has infinitely many solutions. So in this case, our A1 is k, B1 is -1, C1 is -2, A2 is equal to 6, B2 is equal to -2, and C2 is equal to -3. Now, for infinitely many solutions, we know that the condition is A1 upon B1 for infinitely many solutions. So for infinitely many solutions, here A1 upon A2 is equal to k by 6, and B1 upon B2 is equal to -1 by -2, which is 1 by 2, and C1 upon C2 is equal to -2 by -3. Now, for infinitely many solutions, the condition is A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. And putting the respective values gives us A1 upon A2 is equal to k by 6, B1 upon B2 is equal to 1 by 2, and C1 upon C2 is equal to 2 by 3. So we have to find the value of k, but in this case, 1 by 2 is not equal to 2 by 3. So that means these pair of equations are not the valid equations for infinitely many solutions. It has to be all the pairs should be equal. So should be equal. All these ratios should be equal, but we have to find the value of k, but before we find out the value of k, it's b1 upon b2 is not equal to c1 upon c2. So that means this condition has failed here. So there is no value of k for which, even if we put any value of k here, this will not be the case for infinitely many solutions, and this condition has failed here. So our answer for this is it does not exist. Okay, now let's move on to question number 3, where it's given that p minus 1, p plus 1, and q plus 3, these terms are in AP. So if these terms are in AP, that means that common difference should be same. So that means if I subtract p plus 1, p minus 1 from p plus 1, so our d is, that is the common difference, p plus 1 minus p minus 1. This should give us d. And if I subtract this, p plus 1 from 2 plus 3, this should also give me d. So that means this is also d and this is also d, and it should be equal. So let me open up the bracket now, which will give us 2 plus 3 minus p minus 1. So p and p gets cancelled, it's equal to 2, and it's 2p minus p is p, 3 minus 1 is 2, 2 and 2 gets cancelled, so p is 0. So the value of P is 0 for which these terms should be in AP. So correct answer is option C. Okay, now for question number 4, it's given that we have to find the ratio in which the x-axis divides the line segment joining the points. And so we know that if x-axis divides a line segment joining some points, then the point at which this line intersects the x-axis has the coordinates x comma 0. So let's try to get a rough sketch for this. So there, let's say this is the x-axis and it's dividing the line segment joining the points. Let's say we have this point A here, 3 comma 6, and B is minus 12 comma minus 3. Now the line joining these points, this is, let's say, our x-axis is intersected here, and the point of intersection lies on x-axis. So this is x comma 0. But we have to find the ratio. So let's say the ratio is k is to 1. Now we know the section formula. Let's write down the section formula. The section formula gives us the coordinates of the point, that is the point P, and the section formula is m1 into x2 plus m2 into x1 upon m1 plus m2 comma, this is m1 into y2 plus m2 into y1 upon m1 plus m. Okay, so x comma y is this point, so it's x comma 0, and m1 we have assumed that the ratio is k is to 1, so m1 is k, and x2, let's say the x2 is negative 12, so this is negative 12, m2 is 1, and x1 is 3. M1 plus M2 is K plus 1. Now M1 is K, Y2 is, this is negative 3, so this is negative 3 plus M2 is 1 into Y1. So Y1 is 6 upon K plus 1. So this is now equal to x comma 0 is equal to negative 12k plus 3 upon k plus 1, and negative 3k plus 6 upon k plus 1. We have to find the value of k. So let me equate the ordinates. So 0 is equal to minus 3k plus 6 upon k plus 1, and this is now 0 if we cross multiply. So minus 3k plus 6 is equal to 0, minus 3k is equal to negative 6, and k is equal to 2. So k is equal to 2 means the ratio is 2 is to 1, and our option for this is option D is the correct answer. Let's move on to the next page. Okay, so for the next page, our question is question number 5. So in this given figure, this PQ is a tangent to the circle. This is which is centered at O. So O is the center of the circle, and the central angle is AOB is equal to 95. We have to find the measure of angle ABQ. So this is what is supposed to be find out. Okay, so let's try this. Let's draw this right. That the triangle in the middle. Now OA and OB are equal because these are the radii of the same circle. So angle AOB is 90 degree. Now OA is equal to OB. They are the radii of same circle. And these radii with the chord AB, they form the triangle. So angle opposite to the equal sides are equal. So angle AOB is equal to angle OBA because angles opposite to equal sides are equal. And if you use the angle sum property here, this is angle AOB plus angle OAB plus angle OVA is equal to 180 degree. This is because of the angle sum property of triangle. Now we know angle AOB is 95 degree. These two angles are equal, so I'm just going to replace them with OAB with OBA. So instead of OAB, I'm going to put OBA because they are equal, plus angle OBA is equal to 180 degree. Now this is 2 times angle OBA is equal to 180 minus 95, and 180 minus 95 is 5 and 85. So angle OBA is equal to divided by 2, which is equal to 4 7 14.5. The angle OBA is 47.5 degree. Now this angle OBQ is 90 degree. Angle OBQ is equal to 90 degree because radius is perpendicular to tangent at point of contact. Now OBQ it is made up of two angles, angle OBA and ABQ. So this is angle OBA is can be broken down into angle OBA plus angle ABQ plus angle ABQ is equal to 90 degree. Now OBA is 47.5 degree plus angle ABQ is equal to 90 degree. And let's subtract this from 90 minus 47.5 degrees. So 10 minus 5 is 5. And it's 90. So this is 2. And 42.5 degrees should be our answer. So the correct option is option B. Okay, moving on to question number 6. Let me raise this. Okay, for question number 6, it's given that 2 tan is equal to 3 and we have to evaluate the value of the given trigonometric expression. So 2 tan A is equal to 3. We are on to question number 6, which gives us tan A is equal to 3 by 2, and tan A in terms of sine and cos A is sine A by cos A. So let's consider that sine A be 3x and cos A be 2x. This is so let's evaluate now. This is 4 into sine A plus 3 into cos A upon 4 sine A minus 3 cos A. So 4 sine A is 4 into 3x plus 3 cos A is 3 into 2x upon 4 into sine A is 3x minus 3 into cos A is 2x. So this is 12x plus 6x upon 12x minus 6x, which is equal to 6x. Sorry, it's 18x. 12 plus 6 is 18x. It's 6x. X and S gets cancelled, and answer is 3. So correct option is option C. Okay, so we are done with question number 6 and moving on to question number 7, which is based on the second chapter. Okay, so it's given that alpha and beta are the zeros of the polynomial. Let me write down the polynomial. So polynomial is p of x is equal to x squared plus x minus 1. And let's write down the respective coefficients of x squared, x and 1. So x, a is 1, b is 1, and c is equal to -1. Now, it's given that alpha and beta are zeros. So alpha and beta are zeros. Let's write down the sum of the zeros, which is given by b minus b by a. So this is -1. And alpha beta is the part of the zeros, which is c by a, which is -1. We have to find 1 upon alpha plus 1 upon beta. Let's take the LCM, which gives us beta plus alpha. So beta plus alpha is -1, alpha beta is -1, which gives us the answer 1. So A is the correct option. Okay, now moving on to question number 8. We have to find the least value of the A for which the quadratic equation has rational roots. Now, Our given quadratic equation is 2x squared plus kx minus 4 is equal to 0, and a is equal to 2, b is equal to k, and c is equal to minus 4 now. So this quadratic equation has rational roots. What does it mean? So we know that the root of the quadratic equation is given by minus b plus minus root of, if you use the quadratic formula, this is b square minus 4ac upon 2a. And let me put in the respective values, which is minus k plus root of b square k square minus 4 into a, which is 2 into negative 4 by 2a. So this is now x is equal to minus k plus minus root of k square plus 4 to the 8, 8 4s are 4 to the 8, and 8 4s are is 32 upon 2 into a is 2 with, so this should be 4. Now, this whole expression will be a rational number if this is a perfect square. That is k squared plus 32 is a perfect square, because we have to get k squared plus 32 out of the square root, and once the number is in the square root, it should be a perfect square so that it comes out of the square root. And once we have a rational number out from this square root value, so this whole will be, the zeros will be the rational numbers. Okay, now we are more concentrated on square plus 32, so it should be a rational number, that is a perfect square. And if I put k is equal to 0, this gives me the value 32, which is not a perfect square. Now if I put k is equal to 1, that is 1 square plus 32 is equal to 33, which is also not a perfect square. If I put k is equal to 2, this is 2 square plus 32, which is equal to 4 plus 32 is equal to 36. Now this is a perfect square because square root of 36 will give us 6. So the least value of k for which this quadratic equation has rational roots is 2. So this is 2, and our correct option is option B. Okay, moving on to question number 9. Let me erase this. So, okay, so for question number 9, we have to evaluate 3 by 4, 10 square 30 degree minus secant square 45 degree plus sine square 60. Okay, we have to replace the values of, now tan 30 is 1 by root 3, so it's squared, so it's square. Now secant 45 is 2 square, and sine 60 is root 3 by 2 the whole square. So this is now 3 by 4 into 1 by 3 minus 2 plus 3 by 4. So this is now 1 by 4 minus 2 plus 3 by 4. So 1 by 4 plus 3 by 4 is 4 by 4, which is 1. So it's 1 minus 2, and the value is negative 1. So option A is the correct answer for this. Moving on to question number 10. Okay, for question number 10, it's given that the curved surface area of a cylinder of height 5 centimeter. So it's given that the curved surface area is 94.2 centimeters square. So curved surface area's formula is 2 pi RH, which is equal to 94.2, and it's 2 pi into radius. We have to find out the height is 5. This is 94.2. Now R is equal to 94.2 upon 2 pi into 5. And it's given that the value of pi is 3.14. So this is 94.2 into 2 into 3.14 into 5. Okay, so this is 2 4s are 8, 7 are 14.1. This is 47.1 upon 3.14 into 5. And this can be written as, if I multiply them with 100, So this is 4710, then this is 314 into 5. So this gets cancelled, and it's 15, and it's 5, 3, that is 15. So this is 3. So our option is option 3. Again, now let's move on to the next page and try to solve these questions.